Welcome to Dr. Jed's continuing series on calculus. Today's lesson is section 4.5 from Rogowski. That's L'Hopital's rule. So first we'll talk about what L'Hopital's rule is, the definition. We'll compare it with the quotient rule, and I think that's important because that's often a sticking point with students. And then we'll do some examples. Before we do it though, I want to mention who L'Hopital was. He was a mathematician several hundred years ago. This rule is named after him, not because actually he invented it. Actually, it was invented by the famous Bernoulli brothers. But the Bernoulli brothers liked money. They liked to gamble, they liked to spend money and drink, and that cost money, and they weren't rich. L'Hopital was rich. So he came up with a deal. He said, come up with something cool that I can be named after, well, I'll give you some money. And we know this from letters between the two of them. And so it's named L'Hopital's rule because he bought it, basically. Anyway, what is his rule, or Bernoulli's rule, named after L'Hopital? Suppose we have two functions, f and g, and they have derivatives, I'm going to say near some value a. They don't have to be differentiable everywhere, just close to there, because that's where we're going to take a limit. A can be any number. It could also be infinity or minus infinity. It doesn't really matter. What we're going to do is take the limit of f of x and the limit of g of x. Suppose both of those limits are 0. Or conversely, actually it works if both those limits are infinity. If either of those cases are true, the limit of the quotient of f over g, well, that's a problem because if this goes to 0, this goes to 0, what's 0 over 0? It's indeterminate. Or what's infinity over infinity? That's indeterminate. But what L'Hopital's rule says is this limit is the same as the limit with derivatives. And hopefully that works. Hopefully that gets rid of the problem. Now, I want to stress this point. This is taking limits. When you have the limit of this quotient, you can use derivatives this way. Let's take a look. That's what L'Hopital's rule is. The quotient rule for derivatives says if I want to not take the limit of those, but I want to take the derivative of those, I do all of this. Remember that rule? It's important. It's different than this. Don't ever use this as the derivative, because it's not. It's L'Hopital's rule for limits. This is the quotient rule for derivatives. Okay, but talking about it is one thing. Let's do some examples. It's really not that hard to use. Here's our first example. What's the limit as x goes to 2 of x squared minus 4 over the sine of pi x? Well, the first thing to do is see if L'Hopital's rule applies. So we'll call this f of x. We'll call this g of x. What's the limit as x goes to 2 of f of x? Well, if x goes to 2 in there, we get 2 squared minus 4, which is 0, because 2 squared is 4 minus 4 is 0. Here, the limit as x goes to 2 of g of x, likewise, we can just plug 2 in. We get the sine of 2 pi. The sine of 2 pi, if you think about that, is also 0. This is 0. This is 0. It's not to say the functions are 0, but the limits of the functions are 0. If the limit at the top is 0, if the limit at the bottom is 0, then the limit of the ratio is equal to the limit as x goes to 2 of f prime of x over g prime of x. So what is that limit? Well, we need to know what f prime and what g prime are. F prime, f is the top, so the derivative of that is 2x. G prime, well, g is the bottom. What's the derivative of this? Well, the derivative of the sine is the cosine. So there's probably a cosine in there. But there's this pi in here, so it's actually a chain rule. This is the sine of stuff. So the derivative of the sine of stuff would be the cosine of stuff times the derivative of that stuff. And I'm going to put, that's pi, so I'm going to put that in the front. Now, we have a quotient. We could take the derivative again if we wanted to, but notice that as x goes to 2, the top is 4. Automatically, it no longer applies. L'Hopital's rule doesn't apply. That's 4 over something. We get 4 over pi times the cosine of 2 pi. The cosine of 2 pi is 1. That's 1, so we get 4 over pi. This is how you use L'Hopital's rule. Almost every one of them is like this. So let's do another. let's take the limit. Again, it's a limit one, so we know L'Hopital's rule or those kind of ideas can apply. It's not take the derivative, it's take a limit. As x of x ln x. Now this is not a quotient, it's not an f over g. L'Hopital's rule only applies to f over g. So at first you think, well, there's nothing we can do. But if you think about it, we can rewrite this x going to 0 of ln x over, well, over 1 over x. This is the same thing as that. It's a little artificial to write it this way, but that's legitimate. And notice that if I put 0 in here, the top goes to minus infinity, the bottom goes to basically to infinity. Plus or minus infinity are fine. So L'Hopital's rule will apply to this kind of case, where this is our f, and this is our g. By the way, notice I'm using x goes to 0 plus. Why is that? Because 0 minus, the negative sides don't work here. L'Hopital's rule can work on a restricted side. One-sided limits work just as well as two-sided limits. Now, what does L'Hopital's rule say we can do? We take the derivative of f over the derivative of g. That's what the limit is. So this is the limit as x goes to 0. The derivative of the natural log of x, hopefully you know that, that's 1 over x. The derivative of 1 over x, hopefully you can think that one out. You could use a quotient rule. You can use a power rule because this is x to the minus 1 power. You get minus 1 over x squared. Now, if you look at it, we now have the same case that we did before. The top goes basically to an infinity or minus infinity. The bottom goes to a minus infinity. That's awkward. We could apply L'Hopital's rule again. But we don't have to because we can do a little bit of algebra now. Multiply top and bottom by x squared. You end up with, if I multiply by x squared, I get, on the top, x. On the bottom, I get minus 1. Notice, that's not a L'Hopital question. That's a simple, let's just plug in. And as x goes to 0, this goes to, well, minus 0, or just 0. This limit is 0 because of L'Hopital's rule. But you couldn't have done it straight ahead. You couldn't have written the derivative of this one times the derivative of that. L'Hopital's rule doesn't do that. L'Hopital's rule only applies for something over something when both the top and the bottom go to infinity or minus infinity, or when the top or bottom, top and bottom both go to 0. Let's try one more example. Hopefully it's starting to sink in. Here we go. So now we have a top and a bottom. Let's call this our f. Let's call this our g. So as x goes to 5, f of x. This is continuous, so we can plug 5 in. We get 25 minus 5 minus 20. That is 0. Okay. What about the bottom? Put a 5 in there, because this is continuous. 5 times 5, 25 plus 25. That's 50. L'Hopital's rule does not apply. You might have been tempted right away to go 2x minus 1 over 2x. That doesn't work. L'Hopital's rule only applies if you have 0 and 0, or plus or minus infinity and plus or minus infinity. We don't have that, so we have to figure out what to do. Well, unfortunately, we can just plug values in. Because we know what those two are, we can solve this.